I got to make this one now because I haven't all day. So, types, guys. Number 1. What type of reaction do we have?
Synthesis.
How do we know it's a synthesis reaction?
One product.
One product, guys. That's the way every time. It's unique with synthesis. It's one product. Number 2, what type is it?
Decomposition.
Decomposition. Why? One reactant. So synthesis, guys, and decomposition, they're opposites. Synthesis is one product. Decomposition is one reactant. Number 3, what type do we have?
Single replacement.
How do you know it's a single replacement? You just know it? You've got an element, guys, and a compound on both sides of your arrow. We're going to talk a little bit more about it here today. All right, and go through this a little bit more, but that's kind of the gist of it. Number 4, what is it? Again, why is it synthesis? One product. Number 5, decomposition. One reactant breaking down into multiple parts. Number 6, not a double replacement. It's a single replacement, guys, because, now why people think it's double sometimes, because of these elements right here. Cl and Br. But what's unique about those? They're part of what? Brinkelhoff, guys, meaning they are diatomic molecules. So just because they have a subscript does not make them a compound. They are single elements. All right, so you've got an element and a compound on both sides. What is a compound? What's our definition? That goes back to Unit 1. What's the definition of a compound?
2 elements combined together.
2 or more elements, guys, that are bonded together. You do not have 2 different elements there. They are 2 atoms of the same element. They are one element, guys. They are diatomic because they're more stable that way. This is a single replacement reaction. It's a specific type that we will talk about here in just a second. Number 7, what do we have? Synthesis, one product. Number 8, that's a double replacement because you've got 2 compounds on each side. Number 9, decomposition. Again, easiest one in my book that I think to identify because it only has one reactant. And number 10, it's a double replacement. You've got 2 compounds on both sides of the arrow. Guys, this is a resource that should look familiar to you. Where is this located? Guys, this is in your reference packet. So today, we're going to kind of talk through it a little bit. Now, there's a lot more information here, guys, than we need at the present time. This is something we're going to use tomorrow when we predict products. Okay? Right now, we're going to use it. You have it on a test and quiz because it's going to have the types of reactions. It's going to help you to classify what types of reactions you have. So, synthesis, we can abbreviate it with an S. Decomposition is a D. Single replacements, SR. Double replacement is DR. And then combustion is a C. What are the other terms, guys? Instead of replacement, it could also be displacement. Means the same thing. All right? With a synthesis reaction, how we know we have a synthesis reaction is by what? One what? It has one product. That's how you know right away it's a synthesis reaction. Another name you might see for synthesis reaction is called composition. You're combining and putting the pieces together to form one piece. Now, the type that we will see most often in this class is a simple binary compound where we take 2 elements and we combine them together. Guys, the other 2 that you see listed there, we will talk more about those specific reactions when we get to acids and bases in the spring. So wherever you see that term M, or excuse me, the letter M or NM, guys, M just means any metal, NM just means nonmetals. Don't be confused by that. It's just generic. Any metal could be in there where you see the letter M. Any nonmetal could be in there where you see NM. There's no element that is M or NM. All right, like that. So, moving on. Decomposition. How do we know we have a decomposition reactant? Reaction. With one reactant. I've been doing that all day. I did. Answer my own question. One reactant. That's how we know we have a decomposition reaction. All right. Again, most of the time we'll see it with this one. Binary compound breaking down. But we can see any of those. Guys, all those other 5 that are listed there, they're just metallic compounds with different polyatomics. Don't stress over those types right now. All we're trying to do is to identify, is it the most basic one, synthesis, decomposition, single or double replacement, or combustion. All right, that's all we're doing right now. We will talk about the specifics as the year progresses. The next one, single replacement. How we know this one, guys, you're going to have an element and a compound on both sides. Of our reaction. All right, you're going to have an element and a compound on both sides. They're going to be different compounds and different elements, but you're still going to see a single element and a compound, and then another single element and another compound on the other side of the arrow. One of the specific ones you need to remember right now is this last one, this halide replacement, guys, where you have halogens kicking out another halogen. What's unique about pretty much all of the halogens except for astatine? If you look at it on the periodic table, they're what? So fluorine, chlorine, bromine, iodine. What do you know about all four of those? They're diatomics, guys. They are diatomic, meaning in their formula, what are they going to have as a subscript? 2. So don't be confused. Just because you have a 2 subscript does not mean it's a compound. All right, those are single elements. Question? Yeah. RXN is reaction. All right, double replacement, guys. Yesterday, what was the analogy I used to help you remember that? Square dancing. And what was the whole purpose, guys, of saying square dancing? They switch partners. Okay, this will come into play tomorrow when we predict products. So guys, we will switch our partners tomorrow when we get into reaction prediction. Here's what you're looking for to classify it. You have 2 compounds on both sides. Alright? So for double replacement, you've got 2 compounds in the reactants, and you have 2 different compounds on the products. Jake?
Can we abbreviate square dancing by putting a square in the...
If you want to, they're your notes. Abbreviate however you want. And guys, the last one is combustion. Guys, combustion always produce carbon dioxide and water. They will always be the products. And they will always react with oxygen as well. That's how we're going to be able to identify a combustion reaction. Some other reactions may react as oxygen as a reactant, but if they don't produce only carbon dioxide and water, it's not going to be a combustion reaction. All right? All combustion reactions produce carbon dioxide and water as their byproducts. All right? So, leave this resource out. It is in your reference packet, but we're not putting it in our reference packets because you're not going to have the notes on a test or a quiz, but you will utilize the sheet because you have it there at your disposal. So, page 6 in your notes. This is where it's going to kill you guys if you can't name. Like I said, Unit 5 was so important because later on in the year I'm going to give you words. You have to write out the formulas and then be able to predict products and balance equations from those words. Here's where we get into it. If you know you struggle with naming, you've got to put that time in practice. Here we go, guys. The first one, zinc. How do we write zinc? ZN. Oops, that's my highlighter. All right, so there's zinc. Now, lead 2 nitrate. What does that Roman numeral tell us? Charge of what? Lead. Write it out, guys. Pb2+. Oh, look, it's a polyatomic ion. Something you had to have memorized. If you haven't memorized those 7 polyatomics, it's going to cost you now. You're not going to be given them on a test or a quiz. I will only give you guys the 7 that you had to have memorized. If I were to give you another one in a compound, I would give you the formula. Okay? Nitrate. What's our formula for nitrate?
NO3.
NO3 is the formula. What's our charge? Nope. 1 minus. So my formula there for lead 2 nitrate is going to be what? PbNO3, 2. Yield, zinc nitrate. What's the charge on zinc?
Positive.
Positive what?
2.
Yep, it's part of the mini staircase. So therefore, guys, our formula is going to be zinc nitrate. It's going to look just like lead 2 nitrate, except zinc instead of lead. Now how do I write lead by itself?
LB.
Nope.
PB.
PB.
LB.
Now, folks, take a note. Why don't those two elements, zinc and lead, where they're by themselves, why don't they have a subscript? Because they're not Brinkelhoff, guys. Those 7 in Brinkelhoff are the only ones that will have a subscript 2. Any other element by itself will not have a subscript. The 7 with hydrogen, yep. So let's go ahead and balance this, guys. At this point, I'm not going to show the work. I'm going to balance it in my head, kind of talk through it. If you need to show the work, you still should. If I'm going too fast, slow me down. All right, and I will show that out. So I have 1 zinc on the left. How many zincs do I have on the right? 1. Move on to my next metal. I've got 1 lead on the left. How many do I have on the right? 1. How many nitrates on the left? How many on the right? Is this balanced?
Yes.
Oh, look, we don't have to balance it, guys. Sometimes it works out like that. It's okay. Don't freak out. You may not have to sometimes. What type of reaction do I have here? What'd you say? Single replacement. So as we go through these, we're not only going to balance them and write them out, we're going to classify them for practice for our quiz tomorrow. All right, number 2, aluminum bromide. What is the charge on aluminum?
Positive. No, negative.
3 plus. Bromide is 1 minus.
Oh, it is.
So when we write our formula, we get AlBr3 plus chlorine. How do I write chlorine? Nope. Cl2. Brinkelhoff. Guys, it's part of Brinkelhoff. So on your quiz tomorrow, the first thing I would write when I get it, before I write my name, is Brinkelhoff at the top of the paper.
How do you spell that?
Sound it out.
Okay, so B.
Yield. Aluminum chloride, guys, we know aluminum was a 3 plus. What's chloride's charge? 1 minus. So it's going to be the same formula as aluminum bromide, except we have chlorine instead. How do I write bromine out? Br2. Because again, it's part of Brinkelhoff. It's the first one. Now we've got to balance it. How many aluminums do I have on the left? 1. How many do I have on the right? 1. How many bromines on the left? 3. How many on the right?
2.
All right, 3 and 2, they don't mix. We got to find a multiple. It's going to be 6. What do I have to do to the left side? Put a 2. What about the right side? Okay, bromine's balanced, but did I just change bromine in that aluminum bromide compound? I changed aluminum, so I got to balance that out. I've got 2 on the left. How many on the right? 1. So I need to put a 2 there. And then I have 2 chlorines on the left. I have 6 on the right, so I need a 3. Can I reduce this down any further? No. There we go. What type of reaction is this? Nope. Single replacement, guys. This is that halide one I was talking about, where you've got the halogen that comes in and kicks out the other halogen right there. I want you guys to try numbers 3 and 4. Start by writing out the formulas first, then balance them. So when we go to balance these, sodium phosphate's Na3, PO4, no 2 there, just PO4, plus calcium chloride, CaCl2, yields Ca3, PO4, 2. We get those from the crisscross method, plus sodium chloride, NaCl. When I go to balance, I've got 3 sodiums on the left, I've got 1 on the right, so we need to put a 3 here. Go on to my next metal, calcium. I've got 1 on the left, 3 on the right. I need a 3 coefficient to balance that out. Go to my polyatomics next. I got 1 phosphate on the left. I've got 2 on the right, so I need to put a 2 here. That changes my sodium that I just went through and added, so I can erase that. I'm going to put a 6 now, because 2 times 3 is 6. And then the chlorines are taken care of by themselves. So we have 6 on each side. Moving on to the next one. Potassium chlorate, KClO3. Chlorate is one that you would not have to have memorized for your test. I would give it to you. When heated, we got to put the triangle up there or the word heat. Yields potassium chloride, KCl, plus O2. Again, O2 because it's a Brinkelhoff. It's a diatomic molecule when it's by itself, not bonded to anything else. It's going to exist as a pair, as a molecule pair. So everything's balanced except for oxygen. 6 is going to be the common, so I need to put a 2 here. 3 there to get 6 oxygens. By putting the 2 right there, I then need to balance it out here with a 2 as well. So go ahead and work out numbers 5 through 8. 6, write water as HOH. It may be helpful to balance that out. And then number 7, we will do together here in just a minute. All right, so aluminum and hydrochloric acid, Al plus HCl yields aluminum chloride, AlCl3, crisscross method plus H2O. Not H2O, just H2 for hydrogen gas. All right, start with aluminums, they're balanced. Go to chlorines next, we need a 3 there. Those are balanced. Now I've got 3 hydrogens on the left, I've got 2 on the right. That means we're going to need to make it a 6 to balance those 2 out, so we erase that. 6 here, 3 there. Hydrogens are balanced. 6 changes the chlorine. Now we've got 6 on the left, we have 3 on the right, we need a 2 here and a 2 there, and it's balanced. Number 8 I'm going to do next because it's easier than number 6 or 7. H2 plus nitrogen monoxide, NO, yields water. H2O plus nitrogen gas. Again, it's part of Brinkelhoff, so it's a diatomic. Do our nitrogens first. I've got 2 on the right, 1 on the left. I need to put a 2 there. That changes my oxygens. I need to put a 2 here, so they're balanced out, and then balance out my hydrogens in the end. Calcium hydroxide, Ca, OH2 plus phosphoric acid, H3PO4. Have to have that memorized. Yields calcium phosphate, Ca3, PO4 crisscross method. Now with water, you can write it out and keep it as H2O, but it may be a little bit more difficult to balance. So when you see hydroxide, like we have on the left, you see hydroxide on one side and water on the other, write it as HOH because it's much easier to see that hydroxide, and then you can balance it as a polyatomic. It's much easier. 1 calcium on the left, I've got 3 on the right. Need a 3 here to balance those out. Go on to my polyatomics. Doesn't matter which one I go with first. I've got now 6 hydroxides on the left. I need to have 6 over here on the right. Phosphates. I've got 2 phosphates on the right. I've got 1 on the left, so I need to put a 2 here. Hydrogen then is all taken care of. I've got 6 and 6, and it's balanced. All right, number 7. I'm going to jump over here to give myself some more space. This is the answer. Let's work through it. I'm going to erase my work and kind of go through and show you how I got that. So if you're watching this, pause it or skip forward. Don't look at the answers. All right. We will balance them out so they check in the end. Again, we want to make sure law of conservation of matter. Here we go. So I've got here polyatomic. I've got sulfate on this side. I also have it over here, but I also see oxygen right there and sulfur and oxygen over there. Okay? So when you see that, break it up. You're not going to balance it as a whole polyatomic ion. Break it up into the individual elements. So go through 1 copper, 1 copper. I've got 2 hydrogens, 2 hydrogens. I've got 1 sulfur on the left. I have 1 here and 1 here, so therefore I have 2 sulfurs. Oxygen, I've got 4 on the left. Here I've got 4 plus 1 plus 2 is a total of 7. So I've got to go through and balance out my equation now. All right, let's do that. So copper, start with my metals. They're balanced. Sulfur, I've got 1 on the left, I've got 2 on the right. Need to balance it out. Put a 2 there. That makes a 2 for sulfur. Those are balanced. By putting this 2 coefficient in front of sulfuric acid, I then also change my hydrogens. I now have 4 hydrogens on the left. Copper's good. Check that off. Sulfur's good. Check that off. Now I've got hydrogen and oxygen. I also changed my number of oxygens here. I have 8. I'm going to start with hydrogen because 2 and 4 is easier to balance out than 7 and 8. Over here on the right, I need to make this 4. Put a 2 there. Now I've also changed my oxygens. Total oxygens, 4 plus 2 is 8. Oh, look, it's balanced out, and everything's all taken care of.